let's get started then. Good morning, everyone. My name is Bill Newell. I'm the CEO of North-South Studios. We're a content and software development company. And today we're here to talk about augmented reality, about the next generation of apps for education, entertainment, and games, so the entire range. I have been working on augmented reality for the past few years. I'm very excited about the progress that this new technology has made. And I'm hoping to provide you with a very informative session and try to give you an idea of what is involved in creating any of these apps. We have a great panel for you today, and we're going to start by making some introductions. I'll let everybody introduce themselves, and I'll start with you, David, at the very end.
Okay. Hi, everybody. It's working. Okay. My name is Michael Leventhal. I am a partner at the law firm of Holmes Weinberg. I am a business attorney, and I work in the fields of entertainment and digital technology. I've been doing that for longer than I care to admit, and most recently just came out of being the chief legal officer and vice president at Magic Leap. I'm back in private practice now. And I work with a lot of early stage companies and have an emphasis in the AR, VR area, as well as kind of what we can now call the traditional digital media world.
Hello, everyone. I'm Ronan Horowitz, founder and CEO of IQ Vision Technologies. I'm honored, excited, and a little jet lagged to be here today. I just flew 9,000 miles. Yeah, you can go ahead and check in Google Maps what that means. Talking about flying, by the way, I'm going to jump into AR for a bit. I just realized coming into the US this time how AR is becoming part of the mainstream. Normally when I come, I need to pass immigration, and the immigration officer always asks me, what company do you work for? And I say, IQ, what do you do there? Augmented reality, vision recognition, and he's like, what is that? And I need to find a way to explain. Now it went like, what's the company name? IQ, what do you do there? Pokemon Go style games. Oh, welcome to the US. Just like that. So IQ is actually doing vision recognition, which is at the core of augmented reality, and we'll touch a bit more in a few minutes. And with that, happy to be here and share some thoughts together.
Hi, everybody. I'm Brian Blau, and I'm Research Vice President at Gartner. Essentially, I'm a technical analyst, and I look at what we call personal technology market. It's essentially the consumer market. So I research devices, apps, and services. My main coverage area extends through things like consumer social networks, messaging apps. But for today, and to be honest, for most of my career, I've been focused on immersive technology. I got started with VR back in 1988, and I was in the VR sort of industry, if you will, or the market all the way through the 2000s. And it was really exciting then. Clearly didn't take off and didn't happen. I helped invent one technology called Vermal VRML, which is an internet 3D technology that today, sort of 12 or 15 generations later, is called WebGL or Web3D. But it did get its start more than 20 years ago. So I was excited to be there at the beginning, and I'm excited to be here now in a position where I get to comment on the industry. I get a chance to talk to many of the technology producers, whether they be content or hardware or software, as well as many of the businesses that are using immersive technology, or they're starting to use it. So I think I've got a great perspective, and hopefully I'll be able to bring some of that perspective on augmented reality and what it means and what's going to happen in the future. And very excited to be on this esteemed panel today, so thanks for having me.
Thank you, Brian.
Hello, I'm Roy Ashok, Chief Product Officer at DACRI. DACRI is a wearables HMI company. Prior to DACRI, I spent about 12 years at Qualcomm in various engineering and research roles, the last 6 of which I was completely immersed in AR when I co-founded a project called Vuforia that eventually became sort of the de facto platform for creating AR and more recently VR applications for mobile devices. At Daiquiri, I lead all product development, starting with our flagship product, the Daiquiri Smart Helmet, which is targeted at industrial workers to augment and enhance their senses and help them be more productive. So thank you for having us today.
My
Glad
pleasure.
to be here.
David?
I'm Dave Weinstein. I'm the director of ProVR at NVIDIA. Many of you have probably heard of NVIDIA as the sort of gaming company, the graphics card company. We make those, super cool graphics cards that go in your computers and make your games go fast. There's a whole enterprise side to NVIDIA that focuses on all the professional markets, all the professional uses of our graphics card. So I sit on that side of the house. My background is I'm a startup guy, so I did 3 startups in the tech space before joining NVIDIA about a year ago. So happy to be on this panel. Looking forward to the discussion.
Thanks.
Thank you, David.
My name is Jim Margraf, and I'm CEO and founder of iFluence. If I go back to '98, a person with quadriplegia sat with a neurologist, and this man also couldn't speak. And the neurologist decided to go out to Radio Shack and buy some parts and build a device that he could mount on the man's head to allow him to blink and communicate with Morse code. And that was in '98. In the subsequent 15 years, this neurologist, Dr. Torch, in Nevada, Reno, Nevada, developed 7 generations of wearable eye tracking technology. So he mounted cameras in a pair of glasses, put a camera facing the world, put these together, connected to a computer, and allowed individuals with neurological disorders to look at a screen, see letters on a screen and a keyboard, and dwell on the letters to be able to type and communicate. So that happened from '98 until 2012. I happened to meet Bill Torch in 2012, and I'd had the good fortune of founding a number of companies prior to then. I created a device called the LeapPad for children. Does anyone know? Okay. And more recently, I did a smart pen that will write and capture ink and audio called LiveScribe. And so when I met Dr. Torch, looked at what he had done and said, I think there's a way to merge AR, VR, HCI, human-computer interaction, and wearables, because everything begins with intent. We have ideas, we have intentions, and not just people with disabilities. So I founded a company called iFluence to take that technology and now deploy this in AR and VR headsets to allow us to transform intent into action using just your eyes. And I've been doing that now for the last 3 years, and hopefully at the end of this session I'll be able to demonstrate something and show you how you can use your eyes to do some pretty wild things just by transforming intent. Thanks.
Thank you, Jim. Thank you, everybody. So today's session, I'm going to give you, I always like to start with looking at what's going on in the world of AR. And there's a few interesting headlines, over the course of the past 12 months. Of course, everybody knows that Pokemon became a great success, 100 million downloads. It's more downloads and more users than all of VR put together so far. So pretty impressive for a very modest application, actually. Tim Cook was recently at ABC News, and he declared that AR, in his opinion, is going to be bigger than VR, and he looks at it as a cornerstone technology for Apple moving forward. So I thought that was really interesting. We have the emergence of development platforms, just like, as Roy started to say. Vuforia has really grown by leaps and bounds. But we also have the Daiquiri platform that is AR Toolkit, and several other platforms that are enabling developers to create content for AR and VR. An interesting stat that I was looking at prior to the session, there's 336 startups that are listed in the Angels list as companies that are declared as AR. Digital Capital has declared that they are assuming that the AR VR market could hit 150 billion by 2020. So I find all this information extremely interesting and encouraging for anybody that wants to promote, to create applications or use AR as an extension of the products that they create. So I was hoping today in our session to talk a little bit about the key technologies that you need to know about for AR, and then focus the bulk of our time into the next generation of applications, from education to the workforce to entertainment, to gaming, and then perhaps talk a little bit about key factors and things that are useful to know when you want to create one of these applications. Take a look at the present market opportunity and the future market opportunity. Then perhaps take some of your questions and close with a demo from Jim and the iFluence technology. So a lot has happened, and some of the things there are important that have developed in the past couple of years start with technology that is at the heart of the success of AR and VR. So I'll start with you, David. I was hoping that you can talk a little bit about to the audience about the importance of graphic processing units and service on a chip, and the kinds of technologies that you guys are developing that are enabling, empowering all of this technology.
Yeah, sure, happy to. So I think it's important to maybe go back in time 20 years ago, right? And VR and AR didn't happen 2 years ago, right? It wasn't an overnight phenomenon. People have taken stabs at this in the past. And the important thing to look at is what was different this time, right? Was the hype better, and so suddenly we kind of got over that bump? It wasn't about the hype. It was about the underlying technologies and the pieces that you actually needed to create compelling VR experiences. I'm guessing most of the people sitting up here tried VR in the 90s, got nauseous, promised never to try it again, right? And it took 20 years for us to come back to it. The idea is not new. The implementation, the ability to do it right is new. So let's talk about the technologies that you need to do AR and VR. They're still pretty similar. So on the one hand, you need tracking, right? As you move your head, something needs to track that you've moved your head. You need to update the image to match, unless it's just a heads-up informational display. Okay, so tracking is really important. It's also really hard to do with the accuracy and frame rate that you need in order to not have things kind of swim around in AR and VR. So tracking graphics performance, you need to be able to drive compelling content at 90 frames per second. So this isn't simple little images. We all want these immersive experiences that are rich and compelling and have millions of polygons in them. Millions of polygons at 90 frames per second in stereo is actually really hard. Like most desktop applications are pushing 30 frames per second, and that's a pretty good experience. And if it drops out to 20, that's okay. We still don't mind. VR and AR, it's kind of 90 or bust, right? If you don't hit that frame rate, it breaks the illusion of immersion, right? It just kind of falls away. So the requirements in terms of just raw pixels that the GPU has to be able to push through is quite high. And then the displays. So, it used to be really, really expensive to build a display that was this close to your head that had high enough resolution. And then we all got smartphones. And the price of having a high resolution display with millions of pixels in this form factor actually became quite cheap. So these core technologies are what has made VR and AR now possible. There's other ones that I think are important that I hope we'll get to talk to a little bit today. User experience obviously is critical. It's going to be very different than keyboard and mouse, right? Keyboard and mouse don't translate into our virtual worlds. We don't want to be burdened by those. So
definitely, and we'll get to that in just a moment. It's going to be a key part of our presentation. So, but thank you, David.
Sure.
So another key element that is important to know is that to develop content for any of this, AR or VR, one essential component is a development platform. So I was hoping, Roy, that you can talk a little bit about it, having been in a unique position of having worked in Vuforia and now in Daiquiri. So you're familiar with two of the leading platforms, which I have been fortunate enough to use both of them actually, and they work quite well. So can you tell us a little bit about development platforms for AR?
Sure. I think fundamentally the dev platforms for both AR and VR are the same. The tools, the types of problems you're trying to deal with are the same. The approach that I take at least, and that DACRI is very focused on, is to make sure that whatever we do, in general, we're trying to abstract the complexity of AR and VR from the average developer. I think that is very important, because these are not easy concepts to understand and translate. Folks like you guys should be focused on creating, what's the cool content, right? What content and optimizing that content to fit within a CPU budget of saying, okay, I need to render at this frame rate, or I need to have these kinds of particle effects, and this is the hardware that can meet that. More traditional concepts that you've been exposed with. So the approach we take is, let's make the simplest tools easy to use and lower the barriers as much as possible for developers and content creators to use them. So the thing, starting with computer vision, right? The fundamental pieces of technology to enable, what David was talking about with tracking. You basically, when you move your head around or you move your device around, you have to make sure that content that's drawn on someone's head stays where it is in this audience. That's not easy. You need to do that at 30 frames if it's a device like this. You need to do that at least 60 if it's on your head, or 90 would be perfect. That's when you don't see those artifacts. It's not easy at all. We're talking about rendering a complete scene in less than 10 milliseconds, right? So the tools we build have to be very, very highly performant. They have to be exposed in popular tool chains that people already use and are familiar with. So one of the things we do is we make our technology available within the Unity tool chain. So Unity is a very, very popular game engine. You can just pull your content you can model it in any third-party modeling tool and then pull it into Unity, and then it's mostly an authoring tool, a simple authoring experience. And then we take it a step further at DACRI by saying, hey, there are a class of people who don't even want to deal with the sophistication of Unity, right? There's a simplicity that you have to bring there that's simply like, I open up my web browser and I can pull in my 3D model and I just drag it and place it on a scene, and it should just work. And that's the approach we take with our 4D Studio toolchain. If you use a DACRI toolchain, doesn't matter whether you're a really sophisticated developer that needs to bring in your own complex rendering engine for your own game, we support that. You want to bring in, you want to use Unity, widely used, that expertise widely available, we support that as well. And at the other end, if you're not sophisticated and you're not a traditional programmer, but you're a content creator and have these models and you just want to put these together, we would provide that in a simple web app. So if you don't satisfy all these constituents, it's very difficult for a platform to scale.
Thank you, Roy. And actually, we're going to segue right to you, Ronan, since you're in the visual recognition aspect of it. So if you want to further elaborate based on what
Sure.
Roy started to share with us.
So, as I said in my introduction, vision recognition or computer vision is at the core of augmented reality. And I want to explain in a few sentences what that means and why it's so complicated. So let's assume that we want to give our users the ability to point their phone at a movie poster and as a result see the movie trailer or superimpose CGI on top of it. We need to somehow be able to recognize that movie poster. So vision recognition is about giving computers or smart devices the ability to interpret millions of pixels into context. It's basically trying to mimic our human vision. And the complexity, and here's a quick example. When you take a picture with your phone, usually the resolution is very high in today's devices, but let's assume it's 1,000 pixels by 1,000 pixels, which isn't very far from an HD or full HD image. That's 1,000,000 pixels. Now each pixel has 3 values normally, red, green, and blue. That's already 3 million. Now we need to do tracking, as they mentioned here. That means we can't just rely on a single image. We need to work on all those 30 images per second, 30 frames per second. We're now almost at 100 million pixels that we need to do calculations and math and complex learning algorithms, and it has to be in real time and instantaneous. That's how complex it is, but we managed to solve most of those problems. Still, it's a very difficult challenging problem to deal with, but there are ways around to make that work, as we can see already in some applications. So this is basically vision recognition. I want to just quickly say one more thing about augmented reality in general, because we're talking about those terms. From my experience, in my humble opinion, if we look at it from the perspective of the users, the experiences we develop for people, whether it's in toys or games or in the movies, I don't think they really care about the technology name or the technology itself. It's all about, is it fun, right? And I think it's important to realize that, and we'll probably talk about some best practices soon, but that's what drives us when we develop a product in my company. We don't try to put the technology at the center of it. We've learned that with our first product with Lego that they tested with kids, and we realized that kids didn't care about our technology or how we called it. The only thing they cared about was, is it fun?
Thank you, Ronan. And of course, when we're talking about new technologies and we're moving away from the computer and now thinking of eyewear, head-mounted displays, the smartphones, etc., needless to say, an essential component is to rethink how you're going to use the devices, right? So I was hoping, Jim, that you can talk a little bit about what brought you to think about a new UI for all of these technologies, in particular the use of your eyes.
Sure. Thanks. Thanks, Billy. First, a question. How many people here have worn an Oculus? Okay. How many have worn a HoloLens? Okay, about a third. Okay. Who's tried Daydream View, the latest from Google? Okay, just a couple. Okay, thanks. That helps me a lot. So as we look at it, now we have this imagery in front of you. It's VR or AR, overlaid or immersive. How do you interact with it? And we've seen what happened originally. We had Google Glass where you'd swipe your finger along the side panel and look like a Saturday Night Live parody character, which didn't work very well. We see Samsung Gear VR, which still has you tapping on the side of your head and trying to find the buttons. We have Minority Report like hands that are moving around in Tom Cruise style. And we have your head that you can move around and dwell as you hold it in places. And we have your voice. And they're all interesting, and each one brings some value. Or you can use a handheld controller, different types. So what fascinated me was in having looked at it actually looked at users, children, and then adults, how they interacted with paper for about 5 years as I created this LeapPad and watched how their eyes engaged with static images on paper. I became really fascinated with what attracts people's attention, how long they gaze at different objects. So when I met Dr. Torch and started looking at this eye tracking idea, I discovered that the methods of using your eyes to control something were really completely inadequate. And the problem was that the approaches were basically looking at something with cameras looking at your eyes that could track your eyes and see where you're looking, and forcing you to then dwell. So you could look at a menu, you could dwell at it and wait, bing, and then maybe a letter H would be typed. Look at an E, bink in the E, an LLO. Or you could look at something and wink or blink, which got really silly looking as well. Those were the methods that were in all the research papers, and essentially the literature said if you'd like to try to use your eyes to proactively control things, don't bother. And the collision was, how do you deal with this issue of consuming information versus directing and controlling something? And the literature said you can't do both. Well, I take issue with that because right now I'm looking at people and who is directing and who is consuming. Actually, everyone here is doing both right now because I'm looking at your engagement level as a storyteller would, or as a teacher would, or as a speaker would. So I'm taking that information in at the same time that I'm speaking. All of us do this all the time. So I looked at that and said, gee, what could we do? And we came up with a language that allowed us to actually use your eyes to both interact, consume, and control at the same time by again, transferring intent through a mixture of purposeful and non-purposeful eye signals. We looked at your eyes, we derived signals from your eyes, and we looked at the language of light flowing through your brain and how you respond to imagery, and said, wow, could we use this? So my belief is that what we'll see is we'll see hands that are a critical part. You look at Tony Stark in Iron Man, and he holds things up and spins things around. There are times your hands are just great. And there are other times if I'm holding something and I'd like to change its color. Should I have to stop then and use this finger and poke in the air at something or start flicking through a menu? Not if you could look at it and just change the color or check its volume out or find out how much it costs to make. And that you can do just with your eyes as well. So what I see is multimodality in the forms of different type of interactions, whether it's head, hands, voice, or eyes, and eventually brain waves, which we're looking at as well. So I think there's remarkable things coming in this means of interacting in augmented reality to interact, or virtual reality, whether it's quick twitch or you're immersed in a story or beyond. But there's a lot of potential here.
So thank you, Jim. Thank you, everybody. So now let's look at we have talked about hardware, we have talked about platforms, we have talked about UI, we have talked about visual recognition. So Brian, you look at all of these things. So what are your impressions of the new ecosystem that we have going now for this new technology, as opposed to what we were talking about earlier from a couple decades ago?
Sure. Well, there was a lot of interest, 2 decades ago, and you could say that the level of hype around AR, VR really hasn't gone away. What it's turned into was hype that was unrealistic and not achievable to hype, as was described today, sort of modern technology. You can get it. You can sort of go to the store and buy your AR and VR today. The question, was really about sort of the state of the market. I think, sort of where is the industry, what are the types of devices available, and maybe a little bit about where it's going. You could say that 2016 is year one of immersive technology, or year one of AR, VR, even though there's proof positive that the first head-mounted display was, thought of almost 100 years ago. It's been in science fiction, and there's been many attempts at making these types of devices with the thought that having a personalized and central view from your own viewpoint is going to provide you a much more intimate and personal experience for any type of computing or any type of fantasy or entertainment or movie that you want to watch. So today, there are several million head-mounted displays in market. Most of them are VR. Most of them are smartphone VR. Samsung Gear style, where you take a smartphone, you snap it in, and you put that on. The apps today are maybe not what you would expect. The apps in the most popular devices are 2D movies in a 3D theater. They are in fact not really virtual reality, but that's sort of the situation that you have when we're thinking about how technology transitions from one platform to another, from sort of one era to the next. It is a transitionary technology. So today people are using the device which is a new technology device, but they're using it to view old technology. Now, of course, that's going to change. Today, with the wired headsets, that being the Oculus and the Valve and the Sony PlayStation, there's entertainment content there. It's mainly games, and so if you would just look at those only, it's 100% video games, and it will be more video in the future. Besides that, and what's in the consumer market, the consumer is mainly about VR, and for augmented reality, though, it's not in the consumer market yet. It's mainly in enterprise. There are a number of great devices and software systems we've heard about today. There are many different types of use cases that are imagined and that are being pursued by these businesses. They fall into the area of things like field service or maintenance or training. But there are a lot fewer augmented reality devices in market, maybe a tenth of the VR devices. Even though we think that augmented reality and that transparent display component is going to be the future of immersion, it's not the situation today, but we think it will be in the future. So that's a little bit of my view and some of the things that I would.
Thank you, Brian. Michael, you also have worked at Magic Leap, and you have also been looking at different deals and different technologies and partnerships and whatnot. What is your general overview of where the technologies or where AR is today?
Well, I think I'm going to kind of echo what Brian was saying. We're in a situation with AR. AR is a much more complicated thing to achieve than VR, and the component parts are difficult. You have to do everything pretty much that you have to do for a VR device, and then you have to place it in the real world. And you've got all sorts of kind of interface challenges, incredible interface challenges. I was at a concert of one of my favorite bands a couple of years ago. King Crimson was playing in LA at one of the old great movie theaters down on Broadway, and I was up in the rafters, and Crimson is kind of a wall of sound, and I'm sitting there like this in my seat going, all right, because I'm working at Magic Leap at the time, this is all I'm thinking about. I'm like, okay, what's my interface? Because I certainly can't use voice commands here because I can't even hear myself. If I start to move my hands around, I'm going to smack somebody next to me. So, the eye tracking is about the only thing I could come up with. But this is a challenge. I mean, when you look at what we want AR devices to be, we want them to be devices that you can wear all the time and that you can wear outdoors as well as indoors. So the challenge is, it's one thing to sit on your couch and have a closed-in device and play a video game. It's still not easy, but it's doable. But if you want to walk around in the world, you need an interface that's going to work. And if you're going to wear them all the time, and people we see in Minority Report and Agents of S.H.I.E.L.D. and people are swiping and doing that kind of thing all the time, that probably gets tiring after about 5 minutes. You're not going to want to do that for 8 to 12 hours a day. So these things get really challenging. And then of course the other challenge is if you're walking around in the world and you want to see things going on, you want, ads are popping out at you on stores, or somebody's graffitied a building in virtual space. The refresh rates have to be everything we've talked about, but you're in the real world. So where is your data going to be coming from? How fast is the data input in order to to gather that stuff and make it feel seamless? So to me, what I'm looking at right now in AR is there are all these components, and there are all these companies that are doing these things. There's the display technologies. There's which vary from putting something on a screen to projecting onto your retina. There are the interface companies. There are the vision companies. There again interface, and there's the artificial intelligence companies that really need to be there so that they can understand, so that the device can understand what it is you're trying to achieve. And then there's things like spatialized sound, which we haven't talked about yet. If you really want to have a truly immersive experience, audio is an important part of that. So what I'm seeing is an entire ecosystem building up. Now, there's not a huge installed base yet for any of the major platforms, but everybody's kind of building the parts that will come together into an integrated device. And to me, it's a really interesting time. I like that it's year one of, because I think that's true. I think we're starting to see people come out with devices, and everybody. I've had conversations with people who are trying to do smell technologies. So if you're lying in a field of grass, you want to be able to smell that too. So to me, I'm just watching all of these companies kind of look at each other and figure out what the total experience needs to be.
Thank you, Michael. So it's interesting. I love, of course, AR and VR, but I think what is interesting about AR is that it seems to have a lot more applications. And I think that one of the strengths is that it's also not exclusive, it's actually inclusive. And I think that's why Pokemon, which was a very simple app, became so popular and everybody used it, and it became something that we can talk about. We can look at other examples of AR like that, because since you are not losing sense of a reality, you can still ask a peer a question, you can still ask somebody an impression, you can still communicate, and I think that's something that is at the core of AR. I want to make sure that we address the next generations of apps, and I want to ask everybody on the panel to talk a little bit and focus ourselves on uses that are not game oriented. So let's talk a little bit about the real world. Let's talk about the workplace. Let's talk about education and training, and let's try to please everybody feel free to jump in. So I'll start with you, Roy, because
Sure.
Dacre has spent a lot of time on it, but I hope that everybody will participate and will keep the segments a little on the short side so that we can talk also about the entertainment and gaming. It's kind of an ambitious agenda for an hour.
Sure. So at DACRI, we're very focused on sort of reinventing work, as we talk about it as the future of work. What is the future of work going to look like? I think about it more as like, we have to elevate the skill level of everyone here. So in a way that you can think about using AR, someone could be fixing a car today, and maybe fixing an airplane tomorrow and perhaps a surgeon the day after. That's the potential for what AR can do. Where we are today is, of course, early days, but if you think about it, without any formalized training, you should be able to put this device on and you should be able to perform any task that you're faced with on that day. So our belief at DACRI is that, this is it'll all start at work. This technology and the maturity of it today, as Michael alluded to and David talked about earlier, it makes sense today at work. People will wear this. They'll wear it for a few hours. They'll wear it for a work shift. They'll perform tasks with it. At some point, that maturity level will translate to sort of more prosumer use cases and eventually a consumer-grade device and use case. But I think where it really has a lot of bang for buck today is training, maintenance, and sort of using this for tasks that you work on a daily basis.
Thank you, Roy. Ronan, I know you wanted to
Mhm.
jump in there.
Yeah, following up on your comment, I think that training and education has real value with AR because we can suddenly overlay information that is normally invisible to us. So we can show instructions on a certain process and teach someone. I remember that first app, WordLens, that was acquired by Google. Now it's part of Google Translate. You could point your phone at a menu or in a sign on the street and see that in your own language. Beautiful application for AR, I think. One example how we are using AR in one of our own applications, which we just learned that it makes beautiful sense, is we've developed this 3D scanning technology of 3D objects. And we've learned that it's not very natural for people to scan a 3D object. For example, if I want to scan this bottle with my phone, I need to show this from many different angles. And if I just show the camera preview here on the phone, people don't get it naturally to use all those different angles. So what we did, since right now the technology requires to put this background or mat and place the object on top of it, we used that to create an AR 3D dome around that object, divided to different sections. And you just need to carve out those sections while you scan, and it's becoming a lot more fun and addictive. And we can actually put this path on top of it to teach you how to do it in the best possible way. So I think that AR really lends itself to education and training. Again, think schools, chemistry, mechanics, physics. You can really show Newton's law in a way when you make those experiments. So there's a lot of potential there.
Brian, and then you, Michael.
So I just wanted to add a bit about workplace use of AR. So you mentioned it, and of course DACRI is focusing on it, but one of the more popular use cases is field service. So the general category of when an employee has to leave the home office, get in a vehicle or travel to a destination, interact with a client, a piece of equipment, potentially report back that information back to the home office. It's a very common scenario in many types of businesses. And for the tasks, for these field service workers, especially the ones where they have a hands-busy task, they have to repair something, right? Today, they're using maybe paper or a digital tablet, but when they put on that head-mounted display, when they put on that augmented reality device, it frees them from all of the sort of encumbrances of whatever else they had to bring with them, and they can focus on that job. They can have that real-time delivery. So we're seeing this quite a bit, and it may emerge as the most popular use case for AR in the enterprise over the next year. There's going to be the other ones too.
Right.
Training, of course, is really important. Some type of maintenance, maybe focusing on a particular piece of equipment and getting instructions on how to repair it, or getting diagnostic information could be popular too. But those are going to be the ones that at least we're seeing as popular. And I have to say too, it's not limited just to the United States, but this is a global phenomenon. I have a great opportunity to travel around the world and discuss this topic, and the conversations that I have are similar everywhere. Everybody wants to know about it. They want to understand how to use it and how they can improve essentially the efficiency of their business by using a head-mounted display device.
So, Michael, I think you wanted to add something.
Yeah, a couple of ideas. One is a very simple one, which is, how often have you had the experience where you're walking down the street and there's somebody coming towards you and you know them, but you can't remember their name, or you're just stuck, right? So add a little facial recognition technology to your augmented reality device that then automatically summons their LinkedIn or Facebook profile, or maybe your own internal database where you have some information on them, and suddenly you're good to go. That's a dream for a lot of people. That happens to me, so I'm waiting patiently or impatiently for that. And then there's the healthcare field. The healthcare field has a huge number of applications. First of all, imagine that you're a surgeon and you're standing over your patient, and your head-mounted display is giving you a real-time readout or real-time display of the circulatory system and how it's working, or the vitals that the patient is exhibiting right now, and you don't have to look away. I mean, it's all happening right in front of you as you're doing your job. Between that and telemedicine, where you're able to actually perform a surgery remotely through maybe like a robotic device somewhere else, and you've got a fully immersed experience going on. These things are not today, but they are coming, and they could be tremendously valuable and important to saving lives in places that are very hard for doctors to get to.
David?
Yeah, so just a couple of follow-on questions. I think these are great points, and I agree that serviceability is probably the low-hanging fruit. There's a really interesting tie-in, which is to the Internet of Things, right? We have these sensors all around us, and at the moment, they're pretty useless. They're recording a lot of data. Most of us don't have access to that data. The check engine light comes on. I don't know what that means. I have to take it somewhere for them to tell me, oh, it meant your gas cap wasn't totally turned in. I want that information to be accessible. I want it to be the point where I can be my own mechanic, right? So tying into all these sensors, and AR is the right interface, right? I want to be able to look at something and see that information, or be able to pull up that information. So I think Internet of Things is a great tie-in for AR. The second thing I wanted to mention is right now for VR and for AR, they're pretty lonely experiences, right? But they're not going to stay that way long, and it's actually unfortunate that it started that way, because it's in some ways misleading, right? These are going to be probably the most social interfaces that we've ever had, and I don't know how many of you saw the Oculus Connect keynote, but Mark Zuckerberg gets up there and does this cute little collaborative demo where it's him and some friends, and there's the dog, and you should go watch it. It's fun. But the point is, collaboration, I think, is going to be the killer app for both of these technologies. We're a spread out society. Our families live on the other side of the world, on the other side of the country. Our coworkers are all spread out, but we need to collaborate on projects, or we want to spend time with family and friends. And phones are great, and email is okay. None of them are a substitute for being there with someone. And so I think that this technology really holds that promise of being able to share an experience. Whether it's for someone helping you with the surgery, or whether it's watching a movie with mom, I think that's the greatest promise of these technologies.
Thank you, David. So, can we start the next segment with you then?
Sure.
So, we wanted to talk also about entertainment and gaming. And for gaming, I think VR is definitely a more immersive and richer experience at the moment. But just talking about what you just mentioned, David, and I think that the social aspect, that being able to connect with other people, is something that is irreplaceable, and is something that is definitely the reason why, one of the main reasons why Pokemon was successful as a product. So when we talk about entertainment and games, one of the things that always comes to mind, and being here that we're at Digital Hollywood, where a lot of you work with video or develop content or work in a post-production company, you have to think about that AR actually offers you the ultimate second screen experience, because you don't have to stop looking at what you're looking, and you can have an additional experience or an in-depth experience for something that you're experiencing at the moment, but part of the redundancy. So, Jim, you have been involved in education and consumer products. So I thought it would be good to start with you when we're thinking of entertainment, when we're thinking of gaming. What are your thoughts for augmented reality?
Mm-hmm. So, how many people here are in content production? Okay, that's
A
good.
lot.
And how about in technology? Okay, great crossover. So, let's look at what happens now when we're looking at storytelling. And there's this huge topic. I just was at the a conference back east called the Future of Storytelling. Was anyone there? Okay, people know about it. And it was looking at what do we do with this narrative that's well known? What do we do with existing cinematic techniques that are well known? How do we take the idea of giving autonomy to an individual in an environment where suddenly the story that was previously well defined with an arc and beats, now what happens? Because now you can't control necessarily the user's gaze at a point because they can look all around. You can't necessarily control timing because timing is to some degree in the control of the user. How do we deal with this? So we've been looking at this as well, looking at the immersion of this user in what I'll call an IPN, or interactive participatory narrative, okay, where you are a participant in the story. And now we've looked at what's happened with branching stories, and attempts have been made for many years to do branching of all types, and it hasn't really worked very well. One of the challenges, it's invisible because you never see it. You're branching your way through this, but you might not know it. Now let's look at how could we come up with a way to let you participate in a story, to maintain the flow and timing of the story, to use traditional techniques, but still to take advantage of what happens in this immersive environment. So we've been playing with that. We've been looking at some of the interesting, I'll say, biomechanical aspects and cognitive aspects of sight and engagement that are offering some really interesting tools. I'll refer to one or two right now because we're experimenting with these and we're finding huge power that could be as powerful as the invention of the cut when we move from linear filming to actually using cuts. One of those being the blink. It turns out that when you blink, you're blind. Of course, you know that, your eyes are closed. And that blink lasts 150 milliseconds or so. So if one could detect every time an individual in an environment or in an experience blinks, you've got something to play with, which is really interesting. But then again, you don't always blink with the same frequency. But there's something else that happens, and we know this by directing gaze in a film. Your eyes move around. Well, when your eyes move from point to point, in fact, let's just try something. If you would, if everyone looked for a moment at my right finger, and now look at my left finger, and now look back at my right finger, and hold your gaze on my right finger. Now what I'd like you to do, I'm going to get these pretty far apart. I'd like you to move your eyes from my right finger, excuse me, David, from my right finger to my left finger, slowly and smoothly, continuously over a 3-second period. But I want you to start here, and when I tell you to, do it smoothly and continuously over 3 seconds. Ready? Go. But now do it smoothly and continuously for 3 seconds. Okay. You can't do it. You can't do it. It turns out that what's happening is something well known. Your eyes move in what are called saccades, S-A-C-C-A-D-E. A saccade is a hop from point to point. When that motion occurs, there's something else that happens. Now try, look at my finger here, my right finger. Look at my left finger quickly, then go back to my right finger. This, for many people in the audience, about 10 degrees of field of view. The time it takes your eyes to move from my finger to right to left finger is about 43 milliseconds for 10 degrees, plus or minus, very small delta for everybody in this audience. There's something else that happens in that period of time. You're blind. When your eyes are moving from one point to another point, you do not see. Wow. What kind of power is that? Because if we know when that's occurring, when you're in a space and you're watching something, and we can give that to you, and you want to make something happen, you've got two things that can occur. One of them is your eyes are moving from here to here. Well, there's a really nice time to be able to do a cut without having to deal with the issues of sloppiness, because when you're in VR and you're trying to do cuts, it can be pretty nasty. That's the first thing. The second thing is, when you emerge from this blindness, there's another phenomenon that occurs. It's called change blindness. What that means is, when you emerge from blindness, or if you ever watch a figure and you watch a facial change slowly occur, very slowly, you don't see the change occurs. If something happens very slowly, over minutes, you look at a smile and it can change to a frown, and you won't know it unless you think to yourself, I'm watching a smile, it changed. You won't know it. So the idea of change blindness says that if your eyes move from point to point, when you come out of this period of blindness, if something in the scene changes and you were not cognitively aware of it because it's sitting aside, you won't know it until you happen to look over and go, was that there before? I didn't know that. The reason I offer these, I just wanted to get specific in a couple areas because the points that we're looking at right now are techniques that ultimately would be brought forward in tools that will allow us to do things that were unthought of and thought not to be possible. So, very exciting.
Thank you. Anybody wants to add anything to, go ahead.
Well, a much more low-tech analysis. Bill was talking about second screen, and obviously today the viewing of traditional 2D is, you have your television and you may be watching a live event with some friends and you're tweeting or you're texting to your group of friends and all of that. If you're in a device that that gives you a full, gives you the full world, the television can be here and your Facebook page is here and your Twitter feed is here. All of these things can be happening at the same time. And you can be, you can kind of be moving from thing to thing. It allows for kind of a more satisfying, kind of traditional, I guess it's now traditional, two-screen experience.
Thank you, Michael. So we have, time is marching upon us quicker than I would have loved. I do have a lot of information in the PowerPoint. If anybody wants a PowerPoint, you can give me your business card or your email address, and I'll be happy to send it to you. But we do want to make time for a brief demo from Jim. So I wanted to talk to all of you about the market opportunity, and I was hoping that you can give me your highlight for the current opportunity and future opportunity succinctly so I can get to all of you. And I can start with you, Michael, at the far end and just move forward this way. So what do you see as the market opportunity today and tomorrow?
Well, so if you're talking about kind of ultimate consumer adoption or the kind of the whole...
What if somebody wanted to make an app today, what areas or what kind of app would you advise them to do versus what you see, let's say, in about 2-3 years?
I mean, I think probably today, if you're in this whole field, probably the thing that you're going to have the best luck getting adopted and maybe even getting funded for would be an entertainment related or a game app for VR, because VR has the larger installed base. It's more easily understood, and so therefore you have an opportunity to do something in a VR device right now. There's not a whole lot you can do in an AR device just because the installed base isn't really there yet. There are a couple of units that are out there, but I think for the foreseeable future, it's probably on the VR side and on the AR entertainment side, it's games. In the AR world, otherwise, when you talk about the ODG device and the other devices that are actually out there right now, I think it's industrial. That's where it's not entertainment so much as it's working in the factories and instructional and that sort of thing. Big picture is kind of unknowable. I think once AR is really ubiquitous, it just reshapes the entire computing industry and the entire kind of experiential and entertainment industry, because that device will be capable of being pretty much everything that you use today on other screens.
Thank you, Michael. Ronan?
Sure. So I think that the barriers of price, content creation, and distribution of software tools are lower than ever before. But at the same time, the price barrier for high-end VR and AR is still significant. So what I think that's happening now, we're seeing that this market is building itself bottoms up, mobile first, consumer-centric applications. It will change, I guess, but for now that's going to be the build-up, and we've seen Pokemon Go with mobile. We've seen Masquerade or Snapchat filters, which are the most popular apps right now that you can say incorporate an AR experience. I come from Startup Nation, they call it Israel. I'm looking around and I think that in a few years we'll see a lot of development, not just in AR and VR, but also in AI, artificial intelligence, autonomous vehicles. It's going to become big, and the technologies that are being developed for that purpose will combine themselves, I think, with AR Imagine the windshield that will show you some information on where you're driving to, etc. Robotics will also be part of that. So I think that right now we should probably focus more on mobile platforms, but it's going to happen very rapidly that there will be those devices that integrate different technologies together to enjoy the benefits of each different technology segment.
Thank you, Brian. Brian?
I'm going to keep my answer really simple and probably maybe a bit different than the other panelists here. And regardless of the hardware or software, regardless of the state of the platform or how experienced you are, my suggestion, unless you really want to make a piece of hardware, is to focus on content. Think about creating great experiences and educate yourself along the way. What's going to make AR and VR successful ultimately is the quality of the consumer experiences, whether it be entertainment or something else, and in the workplace is how efficient can workers be. I think a lot of the success is going to depend on how good those experiences are. So my advice is to create great experiences.
Thank you, Brian. Roy?
Yeah, that couldn't be further from the truth. You really have to get down to trying to figure out what problem a company or worker or consumer is actually facing. I would say on the enterprise side or the non-consumer side, the focus is on productivity and efficiency gains for industrial workers and field service technicians. I think that's where it'll start. It's a market that can bear that can work with the challenges of the technologies today and the state of where we are. On the consumer side, I'm a little bit more optimistic with the devices we have today. There's very, very clear examples of toys being connected with iPads. Last year there was Lego, or maybe the year before that, Lego Fusion Town Master, very, very successful examples of connecting sort of physical products with digital experiences. So I really encourage you guys to look at sort of the spectrum. I wouldn't rule out one versus the other. There are certain classes of applications that make sense in each category.
David?
So I appreciate the shout out for autonomous vehicles. NVIDIA cares very deeply about autonomous vehicles these days. Seriously. So self-driving cars are coming. They're an enormous, enormous space with lots of money behind it. The same key technologies that are driving AR are driving your self-driving car, right? It's all recognition, it's all tracking, it's all, what are the visuals and path planning and all of that. Those key technologies, I think, are going to have a side benefit, which is that same kind of autonomous agent planning is going to be really useful for media, right? So if I'm building an immersive experience and I want it to be other than just a linear narrative, I'm going to need components in there that respond to me, right? And that AI is going to come from deep learning, right? So I think there's going to be great crossover between those. The last thing I wanted to mention is audio. So if I want to convince you that you're in this room but you're actually back at home watching it, I have to get not just the visuals right, I have to get the audio right too. And people are spending a lot of time thinking about the video side, and NVIDIA is happy about that. We think a lot about graphics too, but there's other senses, and I think that we've spent a lot of time and a lot of years figuring out how to make really compelling visuals, and we're gonna need to start educating ourselves about how to do that from the audio side, from material properties through the physics of acoustic dynamics. So. Anyways, that's where I think we're going.
Thank you, David. So we're going to end with a little different approach than originally planned. We're going to do a little demo with Jim so you can see one of these new technologies firsthand. Before we start the demo, I want to thank the panel. Your companies are really leaders in every aspect of AR and VR, which I do believe is going to revolutionize the way we do things. So I thank you, and I wish I had another hour to ask you a lot more questions. I think we would all benefit from it. So after the demo, if you want to ask us questions, we'll be available. We're all yours, Jim.
Thanks, Billy. So just going back to Brian's comment, on the experience side, couldn't agree more. It is about the type, the quality of experience, the quality of emotional connection, engagement, productivity, speed, time. These things are what matter, and getting those right for a very specific problem to be solved, identifying that problem clearly is the way to go. So be focused on your problem. What I'd like to show you is I have a pair of AR glasses. Who has worn ODG glasses? Okay, few people. So this is a company in San Francisco that makes AR glasses. They're sale for about $2,500. You put them on, they're like a HoloLens, but actually a little broader in their field of view. And so I can see you, I can see through them, and you can see what I'm seeing. What you're looking at right now is a display and the glasses. So here are the glasses. I have these plugged into a battery right now and a small processor that's sitting here. It's an Amazon Mophie battery. But I'll put these on, and the first thing I do when I put them on, so you're seeing what I'm seeing. And right now I'm going to just start looking around. I'm going to move my eyes, here we go, from item to item. I'm moving around counterclockwise. Can you see a box moving? Okay, great. So if you'd like, tell me something you'd like me to look at.
Airplane.
Okay, the airplane. Something else?
Shopping cart.
Shopping cart, airplane, shopping cart, shopping cart, I can go from corner to corner if I want to. I can move around slowly, I can gaze. So I'm looking at things, and what I'm getting is feedback. So as I'm looking, I can see through this. I can see all of you there. This is not overlaid. This is just kind of informational. But there it is. So the next thing that occurs is I say, okay, I can get feedback. I know what I'm looking at. But that airplane, say I'd like to find out, say, what time of flight is. With my eyes, I can bring up a screen that's flight information. And then with my eyes, I can go home and be back there again. And maybe now I'll check out the weather. So it's nice, 81 in Maui would be nice to go to. Now, a couple things. If you watch me and you watch this, you'll see two things. One is I'm not blinking and I'm not dwelling. I'm just looking. I move my eyes around. There's, again, this dialogue that's taking place. Think of it as an agent, an intelligent agent that's watching me, and there's this dialogue that's going on between me and this agent that's giving me, in some cases, imagery in the form of affordances. And then there's signals that I'm generating. Sometimes I'm aware of them, sometimes I'm not. And then there's this balance of actions followed by visual transitions that occur. That's the part of the language that's happening here. So here I go. I'll try again. In the upper right corner, there's a photograph album I'm going to bring up. And I'll tip my head back so you can watch my eyes a little bit here. In the over right, there's an eye. In the upper left, let's go and zoom into the one in the upper left, because this is a favorite photo of mine. That's my wife on the right side, and we were taking our team to Hawaii after our Series A financing, and which is fun. And over there, she and I did that. Wasn't our investors. There's a picture of I'm gonna go back there. A picture of a bamboo forest. We went hiking, and then in the right, there's a picture of eyes. Everyone's eyes. We have pictures of in our building. If I want to, I can flip to the next page, and there's a team picture with 3 members. But if I want, I can pull down a menu, turn on recognition. Are we okay? Is it still there? Okay.
Yeah, no, but
Okay.
we're being told.
We have to hustle?
Oh, we have to
Okay,
hustle.
so now I can look at the individuals, I can see their names. There's Ben, there's Steve, there's Zoe. I'll do one more thing, okay? Here is now I'm a doctor and I want to be hands-free. We talked about medicine. There are my patients coming in today. There's Jeff, there's Eric. Let's check out Eric's charts. There they are, protocols, insurance, confidential information. Current condition, why is he here? Well, he tells us he has pain in his left foot, swelling and bruising. Notice I'm looking, but there's no reticle tracking my eye around. When I get to the bottom, where it says view for the x-ray, I can bring up his x-ray. There it is. When I want, I'm going to go back 2 screens because there was one that said confidential. I'll bring this one up. And now, well, if it's confidential, it takes a picture of my eye because my eye's a better identifier than my fingerprint. So it can authenticate me, say that's Jim, give me access, and now I find out, he had a substance abuse problem. Okay. Last one, Billy, because I set this up for you. I have one where I could make phone calls and do text messages with my eyes and send information, but I'll skip that and we'll go right on to this one, which is, I'm going to turn the camera on now, so I'm going to look at you. And now you can see I'm looking around at everyone here, and I'll look over at Billy. There we go. So if I can use my eyes, by the way, notice I can take these up and down, and I don't have to recalibrate. This is automatic. If I'm looking at the world, I'd like to learn, I'd like to communicate, I'd like to produce, I'd like to buy. Shouldn't I just be able to look at something like a pair, a piece of clothing? Or in this case, I brought along sorry, Dave, some chocolates.
Those are for me.
Yep. So what if I'd like to just say,
It's for the
gee,
panel.
let me look at these. There they are. It's a little dark here. Hold on a second. Okay, there we go. So I'll look at those, and I'll take a picture of the chocolates. We'll hand that picture up to the internet, which can, of course, process that image, identify the image, and note where I was looking. I was looking at the label, which gives it a head start. It sees now if it can find that and match it. If it does, it sends us back information. We take that information and we hand it to Amazon. Well, it didn't do a very good job, but we got some silicon candy round chocolate truffles. Okay, so I can say, let me buy those, and up comes the people. Well, there's Bill. So Bill, would you like some silicon chocolate truffles? Because I'm about to order them. In fact, right now, we just placed a live order, and those will be delivered to you at the address shown there. So there we are.
Well,
Thanks very
thank
much.
you very much. Thank you, everybody. So we'll be available for questions if you haven't at the end of the panel. Thank you for waiting for us. Sorry. Yeah. Okay. Excuse me.